Hello, Skylar Busick's 5th grade science class. Hope everyone is doing great today. Before I get into your questions, I wanted to introduce myself a little bit. My name is Dr. Rahul Patel. I'm an astronomer, and more recently, I am a research analyst, and I do operations research for the U.S. Navy and Marine Corps with a company called the Center for Naval Analyses. If you have more questions about what it's like to do that type of work, shoot me some questions anytime, and I'll be happy to answer. But I'm pretty sure you're interested right now about what I was, and sometimes I'm doing right now as an astronomer. I studied exoplanets, or planets outside our solar system, and the different ways we can find them around their host stars by studying their environments. Now, just to give you an idea, here are some of the telescopes I've been to and used in the past. For instance, here are an array of telescopes on top of the extinct volcano of Mauna Kea in Hawaii. Here's the Palomar Observatory in Southern California, and telescopes atop the mountains in Chile. Now, to give you an idea of how big these telescopes are, here's what Palomar looks like up close, and you can see the door down here and how big the rest of the dome is compared to that dome. Over here you have the inside of the dome right over here, which houses the telescope. And to give you an idea of how big that telescope is, you can see that down here in this little cage, a few people can fit in this little cage. So that just gives you an idea of how big these telescopes are. And here is a fun image of one of the nights that I was working and collecting images with my colleague and friend Ricky while I'm eating a peanut butter and jelly sandwich because, well, I like peanut butter and jelly sandwiches. All right, so if you have more questions about me, let your teacher know, and I'll be happy to send you more answers. So let's jump right into your questions. The first question comes from Jayton. What is an exoplanet? Excellent question. There are 8 planets in our solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Our sun is just another star. And just like our sun has 8 planets, we know that other stars out there, thousands of stars, have planets that go around them. The term exoplanet is a short form for the word extrasolar planet because scientists are sometimes lazy. Extrasolar planet means a planet that is outside of our solar system, and so it's any other planet that is not found in the solar system or not orbiting our star. Basically, planets that are orbiting other stars, going around other stars, and or just floating out there by themselves in space. Second question, and there's no name attached to this one, but let's do it anyways. Does sound travel faster in space? Very good question. For that, we need to see how sound works. We hear things like, let's say, you shouting at your buddy during recess to pass you the soccer ball, or, I don't know, assuming that you all play soccer at recess. Anyway, you yell at someone or talk to someone. When you do that, you're making vibrations in the air. So here's an example of something vibrating in the air, pushing the air back and forth. This is sound. Anything making vibrations in the air, that's sound. This also works underwater too, but we'll stick with air for now. All right, this next question is from Caleb. How do asteroids form? To get there, this story begins about 5 billion years ago when the sun formed. Now, the sun formed out of a really, really large ball of gas and dust, light years and light years across, that came together slowly over millions and millions of years, as you can see from this to this. At the center, that's where things were the hottest and where you found the most amount of gas and dust, and that ball of gas and dust started turning and turning and turning as it started collapsing and coming closer and closer together. At the center is where the sun came to life. It started igniting, it started glowing, and it was born. The rest of the leftover stuff, well, it still kept rotating. And a lot of the leftover stuff, it started clumping up together at different locations from the sun. A lot of those clumps turned into the planets as they coalesced and merged closer and closer together. And those are the planets that we have today. Now, a lot of those clumps, or a lot of the leftover material became smaller and smaller little bits and pieces, are what we now call comets and asteroids. So asteroids are basically bits of rock that was left over from when the sun formed. Now, when I say bits, or really small bits, I mean small compared to the planets, but a lot of these asteroids are really big. Some of these asteroids are even bigger than a lot of cities here on Earth. As you can see, this one particular asteroid, it's about 4 kilometers across, and it basically is larger than one of our really compact cities on Earth. Some of them can be really small, about 700 meters across, or less than a kilometer. But still, that's pretty big. Next question. This comes from Lewis. Why does Pluto not orbit the sun? And how many dwarf planets are there? Au contraire, my good friend. Pluto does indeed orbit the sun. All the planets, planetoids, asteroids, dwarf planets, comets that are in the solar system, in order for them to be in the solar system, they have to orbit the sun. If they didn't, they'd be zipping off into the furthest regions of space. The cool thing about Pluto, though, is that unlike the other planets, which are basically circular and don't cross one another, as you can see here, from Mercury all the way out to Neptune, they're pretty much circular. Pluto, on the other hand, has a very weird and elliptical orbit that sometimes takes it into the orbit interior to the orbit of Neptune. So at times, Pluto is closer to the sun than Neptune actually is. Now, to answer the second question, there are 5 dwarf planets in the solar system. You can check out this little cool infographic I found from space.com. But basically, the 5 dwarf planets are known as Eris, discovered back in 2003, Pluto, which was discovered back in 1930, but recently had the New Horizons spacecraft reach it a couple years ago. And from there, we have some amazing images of Pluto. Haumea, which was discovered back in 2003, Makemake, not make, discovered back in 2005, and the dwarf planet Ceres, which was discovered back in 1801. Now you can see how big all of these dwarf planets are in relation to the size of our moon. And you can see they're all much smaller. They're all smaller than our moon itself. All right, Sam asks, what would happen to the solar system if the sun disappeared? Oh boy, that's a chilling question. Well, at least for us here on Earth, we get all our light and heat and life from the sun. So without it, it would be a really cold and dark mess really quickly. Oh, but other than that, let's consider this. We move around the sun because, one, the sun pulls us in, but we don't fall in because we're moving at a speed and motion that moves us faster than the sun can pull us in, but it keeps us in orbit around it. Now, let's take the motion of a planet around the sun, sort of like this yo-yo, which I'll say is a planet, moving around my finger here, my hand. Now, if the sun suddenly disappeared, meaning if I suddenly stopped holding it, the yo-yo, or the planet, would just fly away into outer space, or in this case, somewhere into my living room, which would not be good for anyone, really. So basically, with the sun disappeared, not only would the worlds in the solar system become even colder and darker, but we would be thrown out into outer space, floating perilously. Anyways, okay, Jakin, or Jackin, I'm really sorry if I mispronounce your name here, asks, why is there less gravity in space? Now, that's a really good question. Gravity is created when there is something, meaning mass, something that has mass. That means you, that means me, that means your teacher, that means the earth, the sun, etc. Everything that we can touch has mass and therefore has a little bit of gravity. The bigger something is, the stronger the gravitational pull, or the stronger that the gravity there. That's why, since people themselves and everything around us is pretty small, we don't feel the same sort of gravitational pull that we do towards the Earth, which is why we stay on the ground, because Earth is so massive. But gravity gets weaker as you move farther away from the thing creating it. So if you were to launch into a space shuttle and leave the Earth's surface, the further you move from the Earth, the less gravity you'd feel until you get closer to something else. So if you left the Earth's surface and traveled towards the sun, you'd be weightless for a long time because there'd be nothing else there until you got close enough to the sun that you'd feel a gravitational pull from the sun itself. So the reason you don't feel any gravity in space is because space is empty. So since you can't have gravity without there being something there to create the gravitational field, in space you'd be weightless because there is nothing there to create gravity. Okay, so Jason's question is, will all 8 planets ever line up? Now, you'd think that at some point in time, in the billions of years since the sun formed, this would have happened. It will not. The reason it won't is because right now, you might think that the planets all orbit the sun only in this direction, meaning that they all go in a circle or ellipse around the sun in a single plane, flat plane. But the truth is that the planets don't orbit the sun in the same plane, meaning that the orbits or the motion of the planets are tilted with respect to each other. So let's take Mars and Earth, for example. If you say that Earth orbits the sun like this, Mars doesn't orbit the sun in a circle that's aligned with Earth's orbital plane. Instead, it's inclined, or it's tilted away from Earth a little bit, so it orbits in this plane. And so there won't really be a lot of times when the Earth, Mars, and Sun will be aligned. And the same goes for the other planets. All the other planets have different orbital planes, or they're inclined differently with respect to each other. And so at no point will the planets align like this. All right, now Cassidy asks, why do some planets rotate different than others? I'm going to assume that you mean, why do they rotate differently on their axis compared to other planets? That's a great question. Well, a lot of different things affect how fast planets rotate. It depends on how they formed, like how fast the leftover material came together to form the planets, because as it's spinning, things that are further away, once they kind of start coming together, will start rotating up faster and faster, sort of like how a figure skater, when they have their arms out, as they're rotating, if they bring their arms in, they start going faster and faster. I recommend watching some figure skating competition videos. They are tons of fun. Now, it also depends on if anything happened in the planet's past to affect its rotation now. So if you were just minding your own business and rotating and just twirling yourself on the floor, and someone came and pushed you over, you wouldn't be rotating that fast anymore. Well, the same thing goes for planets. If something in the past smacked into it and slowed it down a little bit, or even sped it up, that also affects its rotation. So some of this is physics, some of this is random. Now, if the planet rotates too fast, they can break apart. Luckily, none of the planets in our solar system are rotating that fast, so we're all good there. Tanner asks, do you need to learn a lot of math to be an astronomer? Yes. Yes, you do. I took many math courses in college and then used that math when I was studying for my PhD. But here's the secret. I was not good at math. And I used to not like doing any of my math homework until about 9th grade. I was just not good at it. And I would get into tons of trouble with my teacher because I wouldn't do my homework. I was just not good at it. And I would get into tons of trouble with my teachers because I wouldn't do my homework and got into detention. But I kept working at it because I knew it was important somehow. And eventually, after all that hard work, it started making sense to me. I realized that there's nothing to be scared about with math. It's like learning another language. And with enough practice, you can learn to speak it and understand it. Trust me, it's really not that hard. And math can be fun. You can learn to code, and all sorts of jobs require math. So if you like math, great. If you don't, I understand completely. But don't give up, because the end journey is going to be amazing. Alex asks, why is Pluto not a planet anymore? Pluto was the smallest planet in our solar system and the furthest planet from the sun, but as I mentioned before, it is now known as a dwarf planet. Then in 2005, what happened was astronomers found another object further out than Pluto in the Kuiper Belt named Eris. I mentioned that guy as well. At that point, we didn't have a good solid definition of what a planet actually was. And we had also discovered hundreds of exoplanets too by then. So we needed a really strong definition of a planet because we were discovering more and more objects beyond Pluto. And we needed to know if we should categorize or call all of them planets. Because remember, Pluto is also smaller than the moon. So in 2006, the International Astronomical Union, or this international group of astronomers that decide what to name things and what the standard should be for all astronomers and all things astronomy, decided that in order for something to be a planet, the object must, 1, orbit the sun. Pluto orbits the sun, so does Eris. Be massive enough to be pulled into the shape of a sphere, or 3D ball, by its own gravitational force. Fine. Pluto is a round sphere. And it also had to have cleared its neighborhood around its orbit. This means that there must be no other bodies in its orbit that are under its influence. So Eris didn't meet these 3 rules, and so did Pluto. Meaning Pluto didn't meet the 3rd condition, and neither did Eris. Eris didn't meet these criteria either. Pluto hasn't cleared its surroundings of other objects in its orbit, unlike the other planets in our solar system, mostly, for the most part. That's another discussion altogether. So because of that, it was downgraded to a dwarf planet. But that doesn't mean Pluto isn't as awesome as it always was. Back in 2006, NASA launched a mission to go look at Pluto in detail. It launched a satellite that got there a few years ago and took these amazing images of Pluto. Now, you can see what Pluto used to look like and what we've imaged it to be over the last basically half a century. Back when Clyde Tombaugh discovered it, it was nothing more than a few pixels on a screen. And over the years, we've imaged it more and more until New Horizons reached Pluto and took these spectacular images of its surface. So this is what we thought we knew Pluto looked like back in 1996, in 2005, and in 2015, this is the image of Pluto we have now. So it's a fantastic world to study, and it's still rich with information, and we still love it. It's just no longer a planet. Okay, I'm going to pile on the next 2 questions together. Emily's asking, are there any signs of life on Mars? And Andrew asks, do you think we will ever colonize Mars? Both great questions. So let me answer Emily's question first about signs of life on Mars. For a long time, astronomers have suspected that Mars may have been a water-rich world. The evidence for that is from the way the Martian surface looks. From the canyons, the places that look like there used to be rivers or lakes billions of years ago, but are not there anymore. Recently, we know that there's water at the north polar ice cap on Mars, and there might be tons of ice on the surface, and maybe even below that ice there might be even running water. Recently, other astronomers have discovered that there is most likely liquid water about 1.5 kilometers below the Martian surface. Now, why do we care about water? Well, because as far as we know, all living things require water to live. So if we're going to find life on Mars, we need to start looking at where the water is on Mars, or even if, and how much there is and what condition that water is in. Now, going back to Andrew's question of, will we ever colonize Mars? I think that's a great question. I'd like to think so. Right now, there are private companies and governments thinking the same thing, and even testing whether people can live together on the first Martian colony, whenever that will happen. And it's good that people are thinking about it. We are, after all, curious. Humans, I mean. We're always curious, and we want to learn and know more about the world and the universe we live in. We started in caves, and as a people have explored much of the known world. I don't think that we are bound by one world, and will be, and I don't think gravity is enough to keep us down. I know it sounds a little cliched. It'll be up to you all, of course, to build on what we're doing and reach further for the stars than ever before. And with enough determination and teamwork, I think colonizing Mars is a total possibility. And that's all the time I have right now. I know I've left out a few of your questions, but I will try to get those questions answered to you as soon as I can. In the meantime, I hope you enjoyed the answers I provided for your questions. If you have follow-up questions, let your teacher know, and I'd be happy to talk some more astronomy with you all. Enjoy the rest of the year and have a great summer.